In this program, you will learn how to troubleshoot the electrical portion of the Koomey BOP control system. The electrical system is not complicated. In fact, it does the job with a minimum of components and is really simple in design. It should be understood that BOP control is hydraulic and is not dependent upon the electrical system to be completely operational. The electrical panels are provided for remote operation of the system. However, the controls on the hydraulic control manifold are always operational in the event of a failure at one or more of the remote panels. You may never encounter any difficulty with the electrical system, but electrical components do fail from time to time, so we will take a look at some specific electrical failures and see how they affect the system. You've been given a workbook that looks like this. Whenever you are to use this workbook, you will see this sign on the screen. Now, turn to page 1 in your workbook and look at the objectives for this program. This list of objectives tells you what you will learn from this program. As we go along, we will present information related to these objectives. Then you will be given a self-check quiz so that you will be able to see just how well you have understood the information. So, if you're ready, let's begin. Aside from a few hand tools, the only equipment you will need to troubleshoot the system is a VO meter, or one that will measure both voltage and resistance. First, let's look at the major components which make up the electrical system and see what function they perform. We'll begin with the power pack, since this is where the electrical power to the system originates. The power pack serves two major functions. Number one, it converts the rig's AC current to DC. The rig's AC power is connected to the input side of the battery charger, which converts it to DC. The DC current is then used to power the system and keep the batteries charged. The second function performed by the power pack is that of standby power. In the event of a rig power failure, the batteries contained in the power pack automatically take over and provide the correct system voltage, either 120 volts DC or 24 volts DC, that is required to operate the system. These batteries can power the system for approximately 18 hours. However, this time will vary depending on the load requirement of the system. Apart from the power pack, there is a DC series regulator which is used to supply the necessary DC current to the transducers. This regulator is located in the left-hand explosion-proof junction box on the hydraulic control manifold. Voltage output of this regulator varies from system to system. However, the voltage is clearly marked on the cover plate for the regulator. Another component of the electrical system is the solenoid. With one exception, all of the system's solenoids are located in the right-hand explosion-proof box on the hydraulic control manifold. These solenoids are used to operate an air cylinder, which in turn operates a function. Each function on the front of the hydraulic control manifold has two solenoids, one to open the function and one to close it. These solenoids are energized by the corresponding push buttons on the remote panels. The exception we mentioned earlier is the solenoids which are used for the increase-decrease regulators. These are located in the small box behind the right-hand explosion-proof box on the hydraulic control manifold. Another component in the electrical system is the pressure switch. Except for the triplex pump, all of the system's pressure switches are located in the left-hand explosion-proof box on the hydraulic control manifold. Pressure switches are used for several purposes. One of the purposes is to operate the indicating lights on the remote panels. These pressure switches are activated by the pilot pressure for the various functions. When a function button is pushed and the solenoids cause the function on the front of the hydraulic control manifold to shift, pilot pressure is placed on that function's valves. This pilot pressure activates the corresponding pressure switch in the junction box, and in doing so turns on the indicating light on the remote panels. These pressure switches are preset at the factory. Another use for the pressure switch is for the low accumulator pressure alarm. The purpose of this switch is to blow a horn at the driller's panel and to turn on a warning light at the mini remote panel. This is an adjustable pressure switch which may be set to any desired pressure. This is done by rotating the adjusting screw counterclockwise to have the alarm sound at a higher pressure and clockwise to have the alarm sound at a lower pressure. The gray knurled knob is used to adjust the span or differential. The only pressure switch not located in the left-hand explosion-proof box is the one for the electrical operated pump. This pressure switch is adjusted exactly the same way as the accumulator alarm switch. It is located on the front of the pump unit close to the electric pump. Its purpose is to automatically start and stop the electric pump at the system's operating pressure. Relays are another component used in the electrical system. With one exception, all of the relays used in the system are located in the tool pusher's mini panel. They are used in the memory circuit and are activated when a function is transferred from either an open or closed position to a block position. When the block button is pushed, that function's relay keeps the present position light on so that you will know the position of the function while it is in block. Earlier, we said there was one exception in the use of relays. In the hydraulic control manifold and in each of the remote panels, one relay is used in the flow meter count circuit in order to operate the flow meter. Another component of the electrical system is the diode. These are located throughout the system. They are used as arc suppressors across the solenoid coils, counter coils, and relay coils. They are also used to permit testing of all lights by means of the lamp test button. Transducers are another component of the electrical system. They are located in the left-hand box at the hydraulic control manifold. Transducers are used to convert the varying fluid pressure to a varying electrical voltage. This varying electrical voltage is then sent to the corresponding meters on the remote panels. The last component of the electrical system that we will consider is the flow meter. The flow meter has an impulse switch that is used to indicate the 1-inch fluid flow from the hydraulic control manifold to the BOP. The impulse switch sends voltage to an electrical relay circuit, which then sends count pulses to a counter in the remote panels. This counter then feeds the signal into the flow meter on the panel, and the meter registers the fluid flow. Now let's take a self-check to see if you have understood the information that we have covered in this section of the program. Open your workbook to page 2. When you hear the tone, stop the playback unit and answer these questions. When you finish, start the playback unit again and we'll discuss your answers. Now let's discuss your answers. The answer to number 1 is true. Number 2 is also true. The answer to number 3 is A. The other solenoids are located in a small box behind the big right-hand box. Number 4 is B. There are 2 solenoids for each function. Number 5 is C. Number 6 is D. D is also the correct answer for number 7. Pressure switches are used for all of the listed purposes. Number 8 is true. Number 9 is true. And number 10 is also true. The answer to number 11 is false. Transducers are used to convert varying fluid pressure to varying electrical voltage. Okay, now let's look at some specific malfunctions that can occur in the electrical system. To begin with, we will consider the items to check if a function does not operate when the button is pushed. First, try operating the function from one of the other panels. If the function will operate from one of the other panels, this tells you that the trouble is probably in the first panel and not elsewhere in the system. We will cover this more fully in a few minutes. If the function will not work from another panel, next you should make a mechanical check to see if you can find anything mechanically wrong with the system. This procedure is outlined in the program entitled Troubleshooting for Leaks and Malfunctions. Third, make a power check. The easiest way to tell if you have adequate power to the system is by looking at the lights on the panel. If the lights are on and are at full brightness, then you can assume there is adequate power to the system. If you want to be sure of the voltage, check the schematic, locate the input voltage wires, and then use your voltmeter to make sure you have the proper voltage as indicated on the schematic. If the lights on the panel are dim, then there are several items for you to check. First, check the output meter of the battery charger. This should be 120 volts DC or 24 volts DC as required. If you are not getting adequate voltage, then have the rig electrician check the rig's power supply to the system. While you're at the power pack, check the batteries to see that they are fully charged and that the cables are in good condition. Each cell should have a specific gravity of at least 1.265. All system wiring should be checked for loose connections and shorts. And All circuit breakers should be checked to make certain that they are properly engaged. Number 4 on the checklist is the solenoid for the function. Using the junction box layout drawing, you should first determine the correct solenoid for the function you are trying to operate. Remember, each function has 2 solenoids, one to open the function, one to close it. Once you find the correct solenoid, you can make a quick audio check to see if the solenoid is good or not. This procedure requires 2 men, one at the panel where the function did not operate to push the button, the other man at the solenoid listening for a clicking sound. If the solenoid makes a clicking sound when it is energized by pushing the button on the remote panel, then it is good. If the solenoid does not click when it is energized, check the voltage across the solenoid. This is done with one man standing at the panel holding the button down while the rig electrician measures the voltage across the solenoid. The solenoid should read the same as the system voltage. If the voltage check is good and the solenoid still will not energize when the button is pushed, you should loosen the tubing at the fitting on the inlet side of the solenoid and make sure you have air pressure to the solenoid. If you have air pressure at this point, you should change the solenoid coil. This is much faster than changing out the entire solenoid. If the solenoid can be energized from one panel, but not another, this tells you that the problem must be in the first panel or the interconnecting cable. Be sure to check the switch contact block on the non-operating panel. This is done by turning the power off, removing the wire, and checking continuity between the contacts. This should be an open circuit with the switch not depressed, a closed circuit when the switch is depressed. Be sure to turn off the power before checking continuity. If the contact block is good, then check the interconnecting cable for a short or a loose connection. Let's take another self-check. Turn to page 5 in your workbook. When you hear the tone, stop the playback unit and answer the questions in the second self-check. Then, start the unit again and we'll discuss your answers. Now let's discuss your answers. The answer to number 1 is true. Always try to operate the function from another panel. Number 2 is true. These procedures are outlined in the program Troubleshooting for Leaks and Malfunctions. Number 3 is also true. B is the correct answer for number 4. Check the solenoids according to the procedure outlined in the program. Number 5 is true. Always make sure you have air pressure to the solenoid. A and B are the correct answers for number 6. These are the 2 most likely trouble areas. Next, we will consider the items to check when the following malfunction occurs. A button is pressed, the function operates, but the light on the panel does not come on. First, you should press the lamp test button to see if the bulb will burn. If it does not come on, then replace the bulb and see if the function button will light up after the bulb has been replaced. If the new bulb will not burn, next check the lamp socket. If voltage is present, it may be necessary to replace the socket if it is defective. If voltage is not present at the lamp socket in the panel, then use the schematic and check for voltage across the terminals in the remote panel and then the junction box on the hydraulic control manifold. If voltage is present across the terminals at the manifold, then the problem is somewhere in the interconnect between the manifold and the lamp socket. This can be found by working your way through the interconnect until you find the short. If no voltage is present across the terminals in the manifold, then check the pressure switch for that function. This is done by checking the schematic to find the correct pressure switch and then partially loosening the fitting at the back of the explosion-proof junction box to see if there is pressure in the line leading to the pressure switch. If there is pressure in the line, then check all of the wiring for a loose connection or a short. The third malfunction situation we will consider is what to check when a block button is pushed but the function remains where it is or shifts to the other side. If a function is either in the open or closed position and you push the block button but the function does not go into the block position, there are three things to check. Number one, try operating the block function from one of the other panels. This will tell you whether or not the first panel is faulty. Second, check the voltage on the circuit to see if there is the proper voltage as indicated on the schematic. Low voltage can prevent the function from operating when the button is pushed. Third, check the solenoids for that function to see if one of them is bad. The solenoid checkout procedure was outlined earlier in the program. When you press the block button, both function solenoids are energized at the same time in order to go into the block position. If one of the solenoids does not fire, then the function will not shift into block. It will remain in the same position or shift to the other position. Next, we will consider what items to check when the following situation occurs. A function is in either the open or closed position and the block button is pushed. The function operates properly and the block light comes on, but the open or closed position light does not stay on, indicating the position of the function. The problem will most likely be found in the memory circuit, which is located in the mini panel. First, check the schematic to find the correct relay for that function. When you find the relay, the easiest way to check it is to simply replace it with a new one. After you replace the relay, check the function again. Some memory circuits also have diodes. If your system has diodes, make certain you check these with an ohm meter to see that they are good. If the light on the panel is still not working after these procedures, then check the wiring in the memory circuit. The next malfunction we will consider is what to do when several or all of the lights come on when a function button is pushed. When this occurs, there is a shorted diode in the system. Using a voltmeter, check all of the lamp test diodes looking for the shorted diode. These are located in the tool pusher's mini panel. Check the forward and reverse resistance readings of the diode. The forward resistance should be approximately 1,300 ohms. The reverse resistance should be infinite. The readings are taken by carefully placing the leads of the meter on each end of the diode and then reversing the leads. Next, we will consider flow meter malfunction at the remote panels. If a function is activated and a fluid flow is indicated on the manifold flow meter but not on the remote panels, the first thing to check is the input power to the count circuit relay coil in the panel. Refer to the schematic for the proper terminals and check the voltage while fluid is flowing through the system. You should read a pulsating voltage. If you read a pulsating voltage, then check the continuity to the panel meter and the meter itself to see where the problem is. If you read no voltage or a constant voltage, then the relay, the coil, or the magnetic reed switch in the flow meter on the hydraulic control manifold is bad. To check the reed switch in the flow meter on the hydraulic control manifold, first turn off the power to the system. Remember to isolate the batteries so that there is no voltage to the system. When you have turned off the voltage, remove the terminal block cover and start a slow fluid flow through the system. Now you can check the terminals for a pulsating continuity. If the continuity does not pulsate, then the reed relay switch must be replaced. Next, we'll consider meter malfunction. You should remember that the meters on the panels are electric, while the gauges on the control manifold are hydraulic. If you suspect that a meter on a panel is showing an incorrect reading, you should always first double-check it against the gauge on the hydraulic control manifold to be certain that it is faulty before you proceed to repair the meter. Second, if all of the meters on the panel are reading incorrectly, then check the voltage for the system. There is a regulator power supply in the left-hand junction box that supplies voltage to the transducers. The cover plate on the power supply will tell you what this voltage should be. Use your voltmeter and measure the output voltage to be sure it is correct. If the output voltage is not correct, then check the input voltage. If these voltages are both correct, then the meters should read correctly. Adjust the trim pots and recalibrate the meters. If just one meter is reading incorrectly, consult the schematic and check the voltage on the input and output side of the pressure transducer for that circuit. If there is voltage on this circuit, calibrate the meter by adjusting the trim pot on the meter calibration. If there is no voltage on the output side of the transducer, replace the transducer. Let's take your final self-check to make certain that you have understood the information that we have covered in the last part of this program. Turn to page 7 in your workbook. When you hear the tone, stop the playback unit and answer the questions. When you finish, start it again and we'll discuss your answers. Okay, let's discuss your answers. You should have checked D as your answer for number 1. All of the procedures should be followed until the problem is located. Number 2 is true. Number 3 is also true. Number 4 is false. A function will not go into block unless both solenoids for that function are working. Number 5 is true. Number 6 is also true. D is the correct answer for number 7. Any of the above items can cause flow meter problems at the panels. Number 8 is true. In this program, we have covered some of the items to check when troubleshooting the electrical portion of the Koomey BOP system. If you have any questions concerning the information covered in this program, please ask your Koomey representative to help you. Remember, at Koomey, we build the best. There is no equal. The catalyst. If you do, you may get an erroneous reading. 2. If the catalyst is so high in the tube that you cannot get the DP test rig below the pigtail, use a stopper to plug off the pigtail opening. And 3. If the pressure reading is too low, a larger vibrator may be necessary to further settle or pack the catalyst. These large vibrators are very powerful, so extreme care must be taken when using them, or the catalyst could be crushed in the tube and packed too firmly. The outage gauge should be used at the same time the big vibrator is used to quickly note the drop-in catalyst level. It should be used for only short duration vibrations of about 3 seconds each. After the pressure is checked and recorded and is determined to be satisfactory for the time being, the stopper from the upper pigtail is removed if one had been inserted. Next, the operators repeat the loading procedure on the other reformer tubes. Sometimes as many as 600 tubes require a new load of catalyst. After all of the tubes have been loaded, the operators must ensure that all tube pressure readings and catalyst levels are the same. Corrections to the tubes are made by the addition of catalyst and sometimes by using more vibration. If a tube cannot be brought in line with the other tubes in the plant, the operators will have to empty that tube and refill it by the same procedure. After all the tubes are determined to be equal and our customers are satisfied, the tubes can then be recapped. A copy of the data that have been recorded on the forms is then given to the plant personnel. Now that you have seen how a simulated reformer tube job is performed using a dry pack loading procedure, let's take a look at an actual loading job atop a reformer furnace. Note that there is not a lot of workspace here, so each man must perform his duties with care and precision. While 2 men load the cartridges, another man records the loading data. A 4th man brings them their supply of catalyst as they move from tube to tube. Do you see the similarity here between what they are doing and what was done in the demonstration with the plastic tube? This furnace requires about 42 feet of catalyst in each tube. You would assume that if 7 6-foot-long bags were loaded into each tube, we could naturally arrive at the desired 42 feet, right? Well, it seldom happens that way, because no two bags are ever exactly alike. Bags can stretch when they are filled, so one bag could have more catalyst in it than another. Even though two bags might weigh 8 pounds apiece, the catalyst in one of them could take up more space in the loaded tube. Also, there is always a difference in the way the catalyst settles in each reformer tube. You might get 7 full bags in one tube and only get 6 1/4 in another. So, when loading the tubes, always carefully measure, calculate, and correct the loads in each tube individually. We strive for perfection on every job. This keeps our customers satisfied.